Hey, Advanced Algebra 2. We are going to finish up the last little piece of the Chapter 10 notes. And this little part is just on how to solve algebraically a system of equations, and we're also going to sketch a graph for what that looks like. Okay, so just two examples to go through. So the first thing you want to do that's helpful is identify the conic. And so this one, can we tell? There's, okay, well, the change of signs is what is the big giveaway. So can we tell? It's a hyperbola. Okay, and so this is an equation of a hyperbola. And then can we tell what the other one is? Nothing squared, so we go back to a line. Okay, so we're just going to solve the system algebraically. So I think, especially when you have multiple variables that are squared, I think the easiest thing to do is substitution. You could definitely, it's just harder to get it to be elimination because you have to square variables and all sorts of stuff. So I'm just going to do substitution. So x, I'm going to subtract the 6y to the other side. Okay, and now I'm going to plug that in for my x into the first equation. Okay, so we got to FOIL this. Okay, so if we FOIL it, you'd get 18y and then two of them, so we're going to have 36y plus 36y squared minus 9y equals 9. Oh, sorry, this is a square. Okay, so I'm going to combine what I can. The 36 and the 9, I get 27y squared. Minus 36y. I'm actually going to subtract the 9 to the other side, so that's just gone. Okay. I can pull out a 9y. And so we're left with 3y minus 4 equals 0. So we end up with two equations, 9y equals 0. So y would equal 0, or 3y minus 4 equals 0. So y would equal 4/3. Okay, so make sure you just know which variable you're solving for. This was my y, so I'm going to plug that back in to find my x. Okay, so then x would equal 3 minus 6 times 0, so x would equal 3, so that's my first coordinate. And then the second one, the 3 will go in there twice, so you end up with 3 minus 8, so that's a negative 5. So my second coordinate is negative 5/4. Okay, you can plug those coordinates back into either equation. It doesn't matter which one you do. Okay, but now what we're going to do is also graph this. So I'm going to write the hyperbola in standard form, which means it equals 1. So I'm just going to divide by 9. X squared over 9 minus y squared over 1 equals 1. And equation of the line we could also write, so I'd have 6y equals negative x plus 3. Just so they're in standard form, so it's easier to graph. So let's start with the hyperbola. It's centered at 0, 0, which is nice for us. In the x direction, we're going 3. The y direction, we're going 1. So this is going to help me make my box. I'm going to draw the asymptotes. Sort of on a line. Okay. So is this hyperbola opening along the x-axis or the y-axis? And how do you tell? It's opening along the x-axis because the x is the one that's positive. So we're just going to sketch this going like this. And out like that. Okay. So we didn't have to solve for the foci and all the label everything. We're just graphing it. So that's the hyperbola. I'm going to change colors real quick and then we'll draw the equation of the line. All right, so we are gonna draw this. Slope-intercept form is not gonna be all, I mean, it's gonna be helpful, but we're at 1/2. And we're going down 1/6. So we're gonna be pretty far away from here, but that's also the same thing as going down 1/2 and over 3. Do you notice that that's one of our points? So that's good. And then we're also gonna go in the opposite direction, and you can tell that -5 4/3 is going to be on our line as well. Okay, so -5, so 1 2 and then 4/3 is just like 1 1/3. My graph is not that perfect, but there we go. All right, so I'm going to draw my line. Sort of a line, okay? So my intersection points here are -5 4/3 and 3 0. Okay, we're gonna do one more example. So what is this first one? Can we tell? Positive, both same numbers. It's going to be a circle. What is the next one? It's positive, but they're not the same number, so it's going to be an ellipse. Okay, we got a circle intersecting on an ellipse. So here it's kind of interesting because we can have more than 2 intersection points with a circle and an ellipse. So, all right. You could solve this one using substitution or elimination because you have x squared and y squared. I'm going to solve it using substitution, but you could definitely like multiply the first equation by like a -4, and then your x's will cancel out and solve for y. There's whatever you like doing is fine. For the first one, I am just going to say x squared equals 7 minus y squared. And since my other variable is an x squared, I don't actually have to solve and get x by itself. I'm just going to substitute x squared for 7 minus y squared in there. So I'll have 7 minus y squared plus 10y squared equals 40. I'm just going to distribute. Combine these and then subtract the 28. Take the square root. So you get plus or minus 2. So we're going to get 2 answers for y. And then we're going to plug both of those back in. So I'm going to use the first equation to plug it back in. So if I have x squared plus the first one, I'm going to do square root of 2 squared equals 7. So x squared plus 2 equals 7. X squared equals 5. And so x will equal plus or minus square root of 5. So what that means is that for when when your y was a positive, I'm still getting out 2 values for my x. And then I'm going to get the same thing if I do x squared plus negative square root of 2 squared equals 7. X will also equal plus or minus square root of 5. So I'm actually getting 4 solutions. Okay, so you just got to keep track. I have 2 different y's, but they're each producing 2 x's. Okay, so the first equation, x squared plus y squared equals 7. So it's centered at 0, 0. The square root of 7 is like 2.6, 2.5. So I'm just going to go, for graphing purposes, just so I can graph it the best I can. And I'm going to try to draw this. Ooh, that looks terrible. It's a pretty lumpy ellipse. Or sorry, circle. Looks like it's a circle. Okay. The ellipse I'm going to draw in red. So let's just put it in standard form. I would divide by 40. So I'd have x squared over 10 plus y squared over 4 equals 1. Okay, so here I'm centered at 0, 0 again. In the y direction, I'm going 2. And then in the x direction, I'm going square root of 10. So that's just past 3. Okay. Okay, so now we're drawing an ellipse, and I'm going to try to draw this well, but you know, sort of. Okay. So you notice we do have our 4 intersection points. Okay, so I'm gonna, we'll try green. Okay, so like over here on the right, I'm going square root of 2, positive square root of 5. I also have this one, it's not quite lined up perfectly, square root of 2, negative square root of 5. On this side, negative square root of 2, positive square root of 5. And then down here again, they're not quite lined up perfectly. Negative square root of 2, negative square root of 5. So we have all 4 intersection points, okay? So I can write that as square root of 2 plus or minus square root of 5, and then negative square root of 2 plus or minus square root of 5. So those are my 4 intersection points. So you just got to watch out for how many times it's intersecting so you make sure that you keep track of all those coordinates. All right, thanks you guys.